Hi guys, welcome to another video. So let's do this analytical problem together. So it says in the diagram below, D, E and F are 3 points on the Cartesian plane. So we are given these 3 points D, E and F. So let's go through the questions. So the first question says calculate the length of DE. So they want us to calculate the length of this line segment. So we need to apply the distance formula. So we can say distance DE is equals to the square root of xe minus xd to the whole squared plus ye minus yd to the whole squared. And this is equals to, so in the schematic, xe and ye correspond to 3, -5. I've used e as subscripts that correspond to the point E, and same for xd and yd, they correspond to -3 and 3. So if we substitute, xe is 3 minus -3 to the whole squared plus ye -5 minus yd 3 to the whole squared. So this is equals to 3 minus -3 is 6 squared plus 5 minus 3 is -8 squared. So this is equals to the square root of 36 plus 64, which is equals to the square root of 100, which is equals to 10 units. So the next question says calculate the gradient of DE. So they want the gradient for this line. So the answer that we expect is a negative gradient because we have a negative slope. So we can use the gradient formula. Notation once again is important. So small letter m DE is equals to change in y, which is yd minus ye all over xd minus xe. So now we can substitute. Yd is 3 minus -5 all over xd is -3 minus 3. So this is equals to 3 minus -5 is 8 all over -3 minus -3 is -6, which is equals to -4 over 3. So we accept this gradient because our slope is negative. So moving on to the next question, it says determine the value of k if DEF is 90 degrees. So the angle here they're telling us is 90 degrees. So if the angle here is 90 degrees, it means the product of the gradient of this line and that line should give us -1. So let's use that knowledge to find the value of k. So in other words, the gradient of DE multiplied by the gradient of FE should be equals to -1, since DE is perpendicular to FE. This is because DEF is 90 degrees. So we've already established the gradient of DE to be -4 over 3, so we can substitute that into the formula. -4 over 3 multiplied by, we can use the gradient formula here. So we can say ye minus yf over xe minus xf, and this should give us -1. So now we can substitute -4 over 3 multiplied by ye is -5 minus yf is k all over xe is 3 minus -1, and that should give us -1. So this is -4 over 3 multiplied by -5 minus k all over 3 plus 1 is 4 is equals to -1. So we can get rid of -4 over 3 here by multiplying it by its reciprocal. But what you do on the left, you need to do on the right. So we can say -3 over 4 multiplied here and multiply negative 3 over 4. So this and that cancels, negative 3 and 3 cancels. So on the left side you're left with minus 5 minus k all over 4 is equals to 3 over 4. So we can multiply left and right by 4 so that we can get rid of the denominators. Minus 5 minus k is equals to 3. Therefore, k should be equals to negative 8. So the next question says, if k is equals to negative 8, determine the coordinates of M, the midpoint of DF. So we can establish the line DF is this line here, and we need to find its midpoint. So we can say the midpoint, capital letter, notation is important. The midpoint of DF is equals to XD plus XF over 2 YD plus YF over 2. So now we can substitute. XD is negative 3 plus XF is minus 1 over 2, and YD is 3. XF is minus 8 all over 2. So this is equals to negative 3 minus 1 is negative 4 over 2, and 3 plus minus 8 is minus 5 over 2. So this is equals to negative 2 and negative 5 over 2. So finally the last question says, determine the coordinates of G such that quadrilateral DEFG is a rectangle. So now we have to imagine a point G on the Cartesian plane such that DEFG is a rectangle. So we need to find the coordinates of G. So in order for us to find the coordinates of G, we have to take into account a very important property of a rectangle. That is, the diagonals of a rectangle bisect. So that means when they say bisect, it means they meet halfway in the middle. So it means they share the same midpoint. Line diagonal DF and diagonal GE share the same midpoint. So let's use this information to find XG and YG. So you'll recall for rectangle that the diagonals bisect. So in other words, the midpoint of DF is the midpoint of GE. So they share the same midpoint. So let's write this down algebraically. So we can say the midpoint of DF should be equals to the midpoint of GE, which is equals to XG plus XE over 2 YG plus YE over 2. So this can be equated to XG is what we're looking for plus XE. X is 3 over 2, and YG is what we're looking for, which is minus 5 over 2. But remember, we have the coordinates of the midpoint because these two are equal. We found the midpoint coordinates to be negative 2 and negative 5 over 2, so we can substitute it here. So we can say negative 2 is negative 2, negative 5 over 2. And since these two midpoints are the same, it means their coordinates are also the same. So we can equate the coordinates. Let's start with the x coordinates. We can say minus 2 minus 2 should be equals to xg plus 3 over 2. So we can cross multiply. So this here is negative 4 should be equals to xg plus 3. So therefore xg should be equals to negative 7. And the same can be done for the y coordinate. So it's minus 5 over 2 is equals to yg minus 5 over 2. So we can cross multiply. So it's 2yg minus 10 should be equals to negative 10. So 2yg should be equals to 0. Therefore yg should be equals to 0. So therefore the coordinates of g is negative 7 and 0. Thanks for watching. See you in the next one.